In the last couple of videos, we discussed the IUPAC, or International Union of Pure and Applied Chemistry, nomenclature of alkanes. That was videos number 310 and 311. Here, in video 312, what we're going to do is discuss how we would apply this type of nomenclature toward alkenes, molecules that have at least one carbon-carbon double bond. Now, we are going to assume in this video that you have a good understanding of the last couple of videos to jump right into this. So if you need to, go back and review videos 310 and 311 to get up to speed on general nomenclature, because the rules for naming alkanes is going to overlap very, very much with the nomenclature for naming alkenes here. By the end of this video, you will be able to name a molecule such as the one that we have drawn out here. Let's go ahead and take a closer look at this. The information that I have pasted here is taken from the handout for this chapter where we were looking at nomenclature. It's just below the information on how to name alkanes. So to name alkenes, as well as naming alkynes, the rules that we are going to use will be the same as for alkanes, but with some exceptions. Number one, the parent chain, that's the longest carbon chain through the molecule, has to indicate the type of molecule. For alkanes that we were previously naming, we always ended in ane, so methane, ethane, propane, butane, etc., to indicate that all of the carbon-carbon bonds are single bonds. If instead the suffix on the parent name is ene, that indicates there is at least one carbon-carbon double bond or alkene group within the molecule. Similarly, if the suffix is yne, that indicates that the molecule has at least one carbon-carbon triple bond, indicated by yne. So for example, butane with a yne suffix would denote a 4-carbon alkyne, meaning a molecule that had one carbon-carbon triple bond within that 4-carbon chain. Now, to number the longest carbon chain that we did back in the previous video in step number 2 of our nomenclature system, what we will do is always begin at the end closer to the carbon-carbon double bond of the alkene or the carbon-carbon triple bond of an alkyne. So rather than numbering from the end closest to a branch coming off of the chain, which is what we did for alkanes, instead what's going to take priority is numbering from the end of the longest carbon chain that is closer to where the double bond or the triple bond is. And then finally, in order to determine the name of an alkene or an alkyne, we need to specify where that double bond or triple bond is located, because it could in theory be anywhere within the longest carbon chain. And so we list the carbon number where the alkene group or alkyne group begins. So for example, 2-butene would refer to a molecule where starting at carbon number 2, there was a carbon-carbon double bond. So carbon 2 to carbon 3 would be your carbon-carbon double bond there. 2-butyne with a yne suffix would denote there was a carbon-carbon triple bond starting at carbon number 2 of the longest carbon chain and ending at carbon 3. And then from there, the guidelines parallel what we were looking at for alkanes, which is you fill in the branch names, list those in alphabetical order, and indicate their location on the longest parent chain using the same criteria that we did before. And then we will talk about cis-trans geometry in an upcoming segment, so we are not going to worry about that at this point. We will get to that in a later series. So let's go ahead and apply this information. I'm going to zoom out here a little bit so that we can get enough elbow room to dive into an example problem. I've drawn the structure of a molecule here, and we are going to determine the IUPAC name for this molecule. Recognizing that it has a carbon-carbon double bond, that makes it classified as an alkene, so we need to follow the guidelines that are listed here. Now, first step, find the longest carbon chain. That longest carbon chain has to contain the 2 carbons of the carbon-carbon double bond. So tracing out our longest carbon chain, the longest pathway through the molecule that we can get without raising our pencil or backtracking, and that longest carbon chain has to include the carbon-carbon double bond here. So that gives us some clue about where to be looking for this. Finding our pathway through, what I'm going to find as the longest carbon chain is coming through the structure like so. That's going to be the longest pathway we can possibly take. When we get to here, some of you may have been tempted to go up this way with your longest carbon chain, and that would have been absolutely fine as well, due to the fact that this is symmetrical here, that there's a 1 carbon chain coming in each direction. It's tied. In other words, it doesn't matter which way you go, you will come up with the same IUPAC name one way or the other. Now, with this longest carbon chain in place, next thing that we need to do is number that longest carbon chain. And we always begin numbering from the end closer to the alkene or alkyne group. So that means we start numbering from this end, because this is the end of the chain that's closer to the alkyne or the alkene. So ignore where the branches are located when you have an alkene or an alkyne, and number from the end closest to where the alkene group is or the alkyne group. So we're going to number from this end, position 1 there at the end of the line, 2 is that bend, 3, 4 at that carbon-carbon double bond, 5, 6, 7, 8, 9. So there are 9 carbons in this parent chain here. With 9 carbons in the parent chain, if it were just carbon-carbon single bonds, it'd be called non-ane, A-N-E. But since it has a double bond in there, it's non-ene, E-N-E. So I'm going to go ahead and write out that name as our parent name, the last part of the name of this molecule. That by itself is not quite enough, because due to the fact that there's a double bond there, we need to specify where that double bond starts. It starts at carbon 3. Carbon 3 is the lower of the 2 numbers there. So that's what we call the starting point for that. So we would call this 3-non-ene. And in some resources of problems, you may see this referred to synonymously as non-3-ene. Some of the IUPAC committee meetings have slightly altered rules for nomenclature over time and changed what the preferences were. And so over time, both of these terms have at some point or another been acceptable. And so you will often see both or either of those appearing as the IUPAC names for molecules. So non-3-ene is what we will go with here, or 3-non-ene. You can use those interchangeably as the parent name for the molecule. Just remember that when numbering this longest carbon chain, always, always, always start from the end closer to the alkene group, which is what we did here, why we started numbering at the right-hand end of this molecule. Now from there, our guidelines for naming are going to be very analogous to what we have done in the past with alkanes. That is, we need to find our branches. So we had a branch here that we hadn't accounted for. The branches are what we haven't highlighted yet. And we have a branch here that we haven't accounted for. A branch you can recognize as any point where you have a line coming off the parent chain. So there's a line coming off here, so that represents a branch. And I should probably draw that in blue so we don't get it confused with our parent chain. So branch coming off there, that's a line. Branch coming off here, that's a line. Any point where there's a line coming off of the pink parent chain, that would represent a branch. So now to name those branches, our branch at position number 2 of the parent chain, position number 2 here in pink, coming off a 1 carbon chain, we would refer to that as a 2-methyl group, because we referred to a 1 carbon branch previously as METH-YL, meth indicating 1 carbon, YL indicating it is a branch. Now this one here gets a bit trickier. This has 4 carbons in total in this branch. How do we come up with 4 carbons total in the branch? Well, let me map those out for you. There's a carbon here, 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 and here, giving us a grand total of 4. You might be tempted to just refer to this as a butyl group, but that wouldn't quite be accurate, because butyl refers to having the connection to the parent chain at one end of that 4 carbon chain. So the connection would have to be here or here at the end of the chain, but the connection isn't. It's right here in the middle. So what this represents is what we would refer to as a sec-butyl group, or an S-butyl group as the handout refers to it. So S-butyl, and that is going to be at position number 5. So we'd call it 5-S-butyl, separating our number from our letter there using a dash. And if you look at the chart of information on how to name groups, you would see that the S-butyl group is listed out on that chart that was provided in the handout information for naming alkanes and was mentioned in that earlier video on naming alkanes. You would see that the structure for an S-butyl group was sketched out like this. And this squiggly line here that I'm drawing is the parent chain of whatever molecule we're looking at. This is equivalent to the line angle formula that we have here, because it is a 4 carbon chain just like this is a 4-carbon chain. And at the second carbon of the chain is where we connect to the rest of the molecule. And here, it's also the second carbon of the chain. Doesn't matter that you're numbering from the right here rather than the left. These would represent the same structure because if you flipped one over, it would be identical to that. So this is referred to as our S-butyl group. Now let's go ahead and fill in all of this information to come up with the complete IUPAC name for this molecule. We said the parent name was 3-non-ene. Be sure and get that E into the suffix there. Otherwise, you're not naming the proper type of hydrocarbon here. And then methyl and S-butyl, we determine the alphabetization of this based on the M in methyl, and it would, based on current IUPAC rules, be based on the B in butyl, because hyphenated terms, we don't include what's before the hyphen in the current IUPAC rules for naming. So B for butyl, M for methyl, B comes before M, so therefore it would be 5-sec-butyl or S-butyl dash, because we're going to put the number in for the methyl group, 2-methyl 3-nonene as the full IUPAC name for this molecule. Now, as I mentioned in a future unit, we will get into some of the issues with the geometry of these molecules, where we'll be able to describe the carbon-carbon double bond as being a cis bond or a trans bond, which some of that terminology is analogous to how fats are described as trans fats or as cis fats. And we will get into that in a later segment where we focus exclusively on that cis-trans geometry.